Welcome back to PRATIK Academy. In this video, we'll study pressure enthalpy diagram, that is pH diagram. So pH diagram is very important in case of refrigeration field. We have to know how to represent different processes or lines on pH diagram to draw VCR cycle, that is vapor compression refrigeration cycle. So let's see. So as its name indicate, pH diagram, along vertical line there are pressure values, or y-axis represents pressure line, and along x-axis there is a enthalpy scale. This is this y-axis. Here there are pressure values, then enthalpy values along x-axis. Pressure values are given in bar here, and enthalpy values are expressed in kilojoule per kg. Then nature of saturation curve or dome for pH diagram is like this. Okay, this is the nature of saturation curve, and highest point on this saturation curve is called as critical point. Critical point, we know that critical point is the highest value or up to which there is a distinct phase change. Okay, that means below saturation, below critical point, there is a distinct vapor and liquid region, and above there is a no such distinct vapor and liquid region. So below saturation region there are total 3 regions below this critical point. This is the mixture state. Okay, this is the mixed region. Then this is the subcooled region. Okay, this is subcooled region, and this is superheated region. Superheated region. Okay, means here there is the liquid part, here there is the mixture of liquid plus vapor, and here superheated vapors are there, that is vapors which are at higher temperatures than saturation temperatures. Okay, then this is the critical point. Then the curve or part of curve which is along right hand side, this is the dry saturated curve. Dry saturated curve starts from critical point and up to end. This is the dry saturated curve. Then from critical point to left side, this is the wet saturated curve. Wet saturated curve, and total is the saturation curve. Now let's see how to represent some important processes on this pH diagram. So first important process is isobaric process. Isobaric process, or we can call it as a constant pressure process. It is very simple one. As you know, along y-axis there are pressure values. So if we draw any horizontal line here or here, anywhere on this graph, it will represent constant pressure values. So constant pressure lines are drawn horizontally on pH diagram. Next is the constant enthalpy or isenthalpic lines or processes or constant enthalpy process. As we know, along horizontal axis or x-axis there are enthalpy values. Then if you draw any vertical line here, then this line will represent constant enthalpy lines. Any vertical line will represent constant enthalpy line. Then next important line is isothermal line. Isothermal line or constant temperature line. Constant temperature lines. And how to represent constant temperature lines? To represent constant temperature lines or nature of lines is such that in subcooled region it is or left side of saturation curve, they are along vertical, then within curve they are horizontal, and after the saturation curve they are moving in this fashion. So at the entry of uh, saturation curve they are vertical constant temperature lines. within Within this dome or saturation curve they are horizontal, and after crossing saturation curve or after passing saturation curve they are moving along this fashion. So this is the variation of constant temperature line values or lines. Next important is adiabatic lines. Adiabatic lines, or you can call as a constant entropy lines. Constant entropy lines. Then constant entropy lines are shown here by inclined lines. So if we find any inclined line here, then these lines are representing constant entropy lines. Entropy is constant, and there are units are mentioned. Unit of entropy is kilojoule per kg Kelvin, or in some cases kilojoule per kg degree Celsius. So these are the constant entropy lines which are inclined one. Then next important is constant volume lines. Okay. Then constant volume lines are starting from somewhat here. Initially their slope is higher, but as it lines crossing the saturation curve, their slope decreasing. Okay, so these lines or constant volume lines are having this nature. Here volume is constant and this volume is specific volume, so unit mention is kilojoule per kg. So these are the some important lines which are required to draw while our VCR cycle. There is also there is one all remaining important line. It is saturation lines or constant dryness fraction lines. Constant dryness fraction lines. Okay, so dryness fraction lines are starting from critical point here, and nature is somewhat this. This is the constant entropy dryness fraction lines. So here for dry saturated curve, here this is the dry saturated curve as we have discussed. Here dryness fraction x is 1. For this wet saturated curve, dryness fraction is 0, and for remaining lines x is between 1, sorry, from 0 to 1. These are the values. Here will be x 0.9, 0.8, 0.1, and along this line x remains constant. So these are the some important lines for pH diagram. If you like this video, please subscribe our channel. Thank you for watching.